Hi everyone, in this video we're just going to look at question 7 from the transformations worksheet where we compare methods. It's a multiple choice question, so we can do it by calculator. As you can see, it hasn't told us what the transformations are, but you can kind of interpret them if you wanted to, or it hasn't given us function notation. But if we know the relationship between how a point is mapped and function notation, then we can easily do it on the calculator. Otherwise, you just do mapping. So you would just need to rearrange. So for your x, you rearrange that to make x the subject, and then do the same for y. So, and then substitute it into your y equals x squared. So that's how you could do it by hand. If you're doing it on the calculator, which I'm going to show you, so just remember your function notation here. So you've got in the left column the function notation, and then in the right column the change to the coordinate point. So the one that kind of is a little bit confusing could be what is happening to your x. So here, if I just go back to the question, if we have a look at the x, we've got a dilation, a reflection, and a translation. So we do have, if you were to rearrange that and use mapping, you would be fine, but a little bit more confusing when using the calculator. So I've already done this question just to test that it works. So we're just going to define it, and it will make more sense when I talk about function notation in a sec. So we're defining the function. It is an x squared function. All right, so the negative 3x plus 2. So let's just, actually let's deal with the y first of all. So remember, f of x is equal to y. So we're just multiplying f of x by 6. And we're going to subtract 1. All right, so that's the y done. The x and what goes inside this bracket is a little bit more confusing. All right, so we know we've got a translation, so that plus 2, if I just go back to, whoops, here we go. So my, if we look at our coordinate point, we've got a plus c there, but then in our function notation, it's the opposite. So remember, when you do transpose your equation, that's why it becomes minus c. All right, I'm just trying to figure out which window I'm on. Okay, and then we got the calculator. So it's going to be x minus 2. Then we've got that reflection and that dilation. So the 3 is our dilation factor. So if I go back here and we have a look at the very last column, all right, we can see x over b becomes b when we use our function notation. So it's just the reciprocal. Now, if this is maybe a little bit too hard to understand, it might be a good idea to put an example in your bound book. All right, so that's going to be negative 1/3, and that's going to be multiplying the x minus 2. So I'm just going to make sure that my brackets are all correct. All right, now it's going to give me an answer that doesn't look like any of the options there. So don't automatically think, oh my gosh, I've made an error. If we were to, okay, so if we wanted to figure out, all right, which one could it be? I would first of all look at the x minus 2, and unfortunately they're all x minus 2, so we can't really see that. This minus 1, okay, look, I can see that they've taken out a common factor for them. So I would think, okay, what would I take out as a common factor? Probably the 3rd, given that that denominator is 3. So if I take out 1/3 as a common factor, that leaves the 2. All right, so the 2 up here. And then 1/3 times negative 3 gives you that negative 1. So just being able to factorize an expression that is given to you on the calculator, because clearly it's not always going to be in the same form. All right, so can be done on the calculator. If you're struggling to understand what goes inside the bracket, so that negative 1/3 times x minus 2, I've just, and I don't know whether I can highlight this, no I can't, just where the x coordinate is, that negative 3x plus 2 is basically just transposed. All right, yeah, all right.